Alright, into the video too soon. We need to talk about free body diagrams as they apply to like entire systems. A system is essentially just a collection of objects, but it's great if we want to eliminate things. Like, say I have a table, and I've got like a toy car, and I've attached it to a mass. Well, let's say this toy car is headed to the left. I can draw a free body diagram for just the car if I wanted. Normal force, gravity, and the tension. Maybe it's moving to the left because of its own motive power, so maybe it's got like that frictional force pushing it forward. In this case, it would actually be a static friction. We'll talk about that later. And then we got the block here. We would have a tension force and its own weight. We need to be careful here since we're talking about two objects. We'll probably want to distinguish the masses. So mass of block. If you don't distinguish those masses, it would be read as them both having the same gravitational pull from the Earth, and we don't want that. That's not correct. If the string is massless, we know the two tensions are the same. And we would know that because this section here does not have to support the mass of this section, and so forth and so forth. So the tension is the same throughout. But we can also draw it as one big system. And again, we only draw external forces. So we would have the weight of the car, the normal force, that static friction pushing it forward, and then the weight of the block. We would lose out on the tension here because it's internal. These two would just cancel out. The tension pulling the car back and the tension pulling the block up would not be needed. They're internal, they're going to cancel out. So that's another way we can do free body diagrams. We can draw them for an entire system of objects, like if I'm stacking blocks. The bottom block acts on the middle acts on the middle acts on the top, and the top acts on the middle. If we want to get rid of those, if we don't want to worry about that, we can treat it as one big stack, where we just have gravity pulling on all three blocks, and if they were sitting on a table or something, we would have the normal force from the table. That's another way to do it, is just to look at the whole thing as a system or a collection of objects.